Hello friends, I welcome you in lecture number 1 on series. In this lecture, we are going to discuss about convergence and divergence of an infinite series or simply of a series. So first we recall what is meaning of series. So as we know, if we have some sequence an, then if we try to add the terms of this sequence an, then we get an expression of this form a1 plus a2 plus a3 and so on. So this expression is called an infinite series or just a series, and these are the familiar notations for series. We can denote series by sigma n equal to 1 to infinity or simply sigma an. The number an is known as nth term of the series. So we will see that how to decide the convergence or divergence of this infinite series. So suppose we have this infinite series sigma an which is a1 plus a2 plus a3 and so on. So we want to discuss about convergence and divergence of this series. So suppose sum of all the terms of this series, if we add all the possible terms of this series and if this infinite sum is finite, then we say that the series is convergent. If the sum of the series, or if we add all the terms of the series and if that infinite sum has finite value, then series is known as convergent series, and if this infinite sum is not finite, series is known as divergent. So our aim in this chapter is to decide whether the sum of infinite series is finite or not. That means whether the series is convergent or divergent. So convergent series means the sum of the series is finite, divergent series means sum of the series is not finite. Now how to decide whether sum of the series is finite or not? Because there are infinite number of terms in this series, it is not possible to find out sum of the series by adding each and every term, because there are infinite number of terms in this series. So how to decide that this summation has finite value or it has no finite value without adding the terms of the series? So we will focus on this problem throughout this chapter. That is, we will try to decide whether sum of the series is finite or not, or in other words, we will try to check whether the series is convergent or divergent. So there are different results to decide the convergence or divergence of the series. We will discuss them one by one. So first result which we will discuss is the definition of convergence. Suppose we consider sigma an, that is, if we consider this series an, then we can write this infinite sum as a limit of finite sum. Suppose I consider addition of first n terms of this series, say a1 plus a2 up to an, and if I want to write this series in terms of limit, then here I should consider limit as n tends to infinity. So I am writing the infinite sum as a limit of finite sum. So if this limit exists and it is finite, then series is convergent, and that limit is nothing but sum of this series. So we will denote this finite sum by Sn. Sn means sum of first n terms of the series. So that Sn is known as nth partial sum. We are taking sum of first n terms of the series. So Sn is known as nth partial sum of this series. So suppose we consider S1, then we are writing first term of the series. If we consider S2, that means sum of first two terms of this series. If we consider S3, then sum of first three terms of this series. And in general, Sn is nothing but sum of first n terms of this series. So you can see we obtain a new sequence whose terms are S1, S2, S3 and so on. This new sequence is known as sequence of partial sums of given series. Sequence of, because we are taking partial sums of given series. So if this sequence is convergent, or if limit of Sn exists, then this series is convergent, and if limit of Sn does not exist, this series is divergent. So in this lecture we will see how to decide the convergence or divergence of this series by the definition of convergence of series. That means we are going to use limit of nth partial sum. So if we are able to determine the limit of nth partial sum, then we can decide whether given series is convergent or divergent. But it is not possible to decide this limit for every series. So for that we will develop some another results in upcoming lectures. But in this lecture we will do those type of problems in which we are able to decide the limit of nth partial sum of this series, so that we can decide the convergence or divergence of given series. So first we have written the definition of convergence of series. So suppose we are given a series sigma n, we define nth partial, we define sequence of partial sums whose first term is first term of this series, second term is sum of first two terms, third term is sum of first three terms, and nth term is sum of first n terms. So this sequence Sn, whose terms are defined as partial sums, is known as sequence of partial sums of given series, and this Sn is called nth partial sum. So if limit of Sn exists, or if sequence Sn is convergent, sequence Sn is convergent if limit of Sn exists. So if sequence of partial sums, sequence Sn is convergent, then sigma an is called convergent, and if this sequence Sn is not convergent, or if limit of Sn does not exist, then series is called divergent. Now in the case if limit of Sn exists, then sum of this series is nothing but limit of nth partial sum. And here we have written if limit of Sn does not exist, or if sequence Sn is divergent, series is divergent. So we understand this with the help of example. Here we are asked to prove that series sigma 1 over n into n plus 1 is convergent, and we have to find its sum. This series is known as telescoping series. So we use the definition of convergence of a series. First we write down given series is sigma n equal to 1 to infinity 1 over n into n plus 1. So the nth term of this series is an equal to 1 over n into n plus 1. So we can rewrite this nth term as we replace this 1 by n plus 1 minus n, and here we have n into n plus 1. So therefore nth term is rewritten as we divide n plus 1 by n into n plus 1, so n plus 1 will cancel out, and n divided by n into n plus 1, so n will cancel out. So this is the nth term of given series rewritten in another form. N belongs to n. Now we find out the nth partial sum. So the nth partial sum Sn is nothing but sum of first n terms of given series. So suppose we consider n minus 1th term plus nth term. So therefore Sn equal to, so first we write down a1 can be obtained from this equation for n equal to 1. So we have 1 by 1, which is 1 minus 1 over 2. So a1 is 1 minus 1 by 2 plus a2 is 1 by n, that is 1 by 2 minus 1 by n plus 1, that is 2 plus 1, 3. a3 is 1 by 3, here we put n equal to 3, and we have minus 1 by 4 and so on. N minus 1th term will be, for n minus 1th term we replace n by n minus 1 here, so we have 1 over n minus 1 minus 1 over n minus 1 plus 1, that is 1 by n. So n minus 1th term is 1 over n minus 1 minus 1 by n, and nth term is 1 by n minus 1 by n plus 1. So now we can observe that here all the terms are in the addition, so these two will cancel out, minus 1 by 2 plus 1 by 2. This 1 by 3 will cancel out with this, minus 1 by n will cancel out with this 1 by n, minus 1 by 4 will cancel out with its next term, and this 1 by n minus 1 will cancel out with its previous term. So we are left with 1 and minus 1 by n plus 1. So our nth partial sum is simplified so that we can easily decide the limit of nth partial sum. So Sn is 1 minus 1 over n plus 1. So therefore limit of Sn as n tends to infinity is limit of 1, which is 1, and limit of 1 by n plus 1 is 1 by infinity, which is 1 minus 0 is 1. So therefore limit of Sn exists as n tends to infinity, or we can write that sequence Sn is convergent. So therefore by definition, because sequence Sn is convergent, given series is convergent and its sum is, given series was sigma 1 over n into n plus 1 by n into n plus 1. This sum is equal to limit of Sn, which is 1 here. So sum of given series is 1. So in this way we can use the definition of convergence of a series to prove that given series is convergent, and we can decide its sum. So what we have done is, we have first written nth term, we simplified nth term, and then we find out nth partial sum, and we see that nth partial sum gets simplified so that we can easily decide its limit, and limit of Sn exists. Therefore given series is convergent and sum of given series is equal to limit of Sn, which is 1. We consider one more example. Check the convergence of this series sigma tan inverse n minus tan inverse n plus 1 as n equal to 1 to infinity, and find its sum if the series is convergent. So first we write down nth term of the series. It is an equal to tan inverse n minus tan inverse n plus 1. Now we write down the nth partial sum, which is sum of first n terms of given series. So a1 will be equal to value of this at n equal to 1, which is tan inverse 1 minus tan inverse 2. a2 is tan inverse 2 minus tan inverse 3. Similarly, a3 is tan inverse 3 minus tan inverse 4. a4 is also written as tan inverse 4 minus tan inverse 5. an minus 1, that is n minus 1th term, is tan inverse of n minus 1 minus tan inverse of n minus 1 plus 1, which is n. So n minus 1th term is tan inverse of n minus 1 minus tan inverse n, and nth term is tan inverse n minus tan inverse n plus 1. So here also we can see tan inverse 2 will cancel out, this will also cancel out, tan inverse 4 will cancel out with this, tan inverse n will cancel out with this will cancel out with its previous term, and this will cancel out with the succeeding term. So finally Sn is equal to tan inverse of 1 minus tan inverse of n plus 1. Tan inverse 1 is pi by 4, and we keep this as it is. So now we take limit on both sides. Limit of Sn equal to limit of this, which is equal to limit of pi by 4 minus limit of tan inverse 1. Pi by 4 is independent of n, so its limit is pi by 4, and here if we take n tending to infinity, we have tan inverse infinity, and tan inverse infinity is pi by 2, and pi by 4 minus pi by 2 is pi by 4 minus 2 pi by 4, which is minus pi by 4. So therefore limit of Sn exists, and therefore given series is convergent, and its sum is limit of Sn, which is minus pi by 4. Next example is check the convergence of this series 1 square plus 2 square plus 3 square plus 4 square and so on. So given series is 1 square plus 2 square plus 3 square and so on, which we can denote by sigma n square, where n equal to 1 to infinity. So here nth term is n square. So nth partial sum is Sn equal to sum of first n terms a1 plus a2 plus a3 plus an. So a1 is 1 square, a2 is 2 square, a3 is 3 square and so on. So limit of Sn is limit of 1 square plus 2 square plus n square. So this is the sum of squares of first n natural numbers, and we have a ready-made formula for this sum, which is n into n plus 1 2n plus 1 by 6. So that we write here, and here if we consider limit as n tends to infinity, we obtain infinity. So that means limit of Sn does not exist, or we can say that sequence Sn is divergent, or sequence Sn diverges to infinity. So therefore given series is also divergent. So in this way we can check whether series is convergent or divergent simply by considering limit of nth partial sum, which is sum of first n terms of this series, and we have denoted sum of first n terms by Sn. So this is the main logic which we have used here. This infinite sum is written as limit of this finite sum, and if this limit exists, series is convergent. If this limit does not exist, series is divergent. So whatever problems we have taken in this lecture, we are able to decide this limit, but for every series it is not possible to decide the limit of this nth partial sum. For that we have to use some other results. So from next lecture onwards we will discuss some another tests which are known as convergence tests to decide the convergence or divergence of given infinite series. So this is all about this lecture. I hope you like this lecture. Keep watching. Thank you very much.